Hey guys, Marco here from Aviator Live CS. Welcome back to my channel. Today we will complete the electrical system, and this is part 4. We will be talking about electrical system abnormal operations and the electrical system FCOM Volume 1 Supplementary Procedures. So let's start with the abnormal operations. Today we are going to focus on the non-normal checklist we have available here, with the exception of the smoke, fire, or fumes non-normal checklist. We will talk about this one later on in a different video. Let's start with the battery discharge non-normal checklist. Condition: a battery discharge exceedance of course. Note: a fully charged battery supplies a minimum of 30 minutes of standby power. And if we have an auxiliary battery installed, like in this case, and here we have the light, it says fully charged batteries supply a minimum of 60 minutes of standby power. Now let's talk about the drive non-normal checklist. Condition: a generator drive malfunction of course. Action is irreversible. Generator drive disconnect switch affected side confirmed. Hold in the disconnect position momentarily. This prevents generator drive damage. And here we have it in the panel. Here we have the lights, and here's the disconnect switch. Choose one. APU is available for start. If it is, APU start. When APU is running, APU gen switch affected side on. If APU is not available, plan to land at the nearest suitable airport. Only one main AC power source remains. Something about the disconnect switch I found in the MRG. Thank you again to Captain Pat Boone for allowing me to use some extracts of his great MRG app. The drive disconnect switch is spring-loaded and must be held in down position for at least 1 second. Do not press the drive disconnect switch for more than 3 seconds because the disconnect solenoid melts when powered for 5 seconds. One more thing about this non-normal checklist: it says it should be accomplished anytime the amber light illuminates in flight and the associated engine is running. So you do this non-normal checklist for all kinds of electrical failures, but not after an engine failure or shutdown. All right. So now let's talk about the elect light and non-normal checklist. Here is where we can find the light. It says condition: a standby power or DC system fault of course. Note: the elect light illuminates on the ground only. Do not take off. Now we will talk about the loss of both engine-driven generators, and this is a quite long checklist. And these are the lights we are expecting to see if we find ourselves in this situation. Now, a few comments before we start reading the checklist. According to the MRG, it says make sure you are not dealing with a single or dual engine failure. Advanced thrust levers and verified engine response. Verified engine fail is not displayed. Now, what happens if we get this situation during the takeoff? Let's read what the MRG says. It says do not reject takeoff if airspeed is above 80 knots. The anti-skid system is partially inoperative. V1 with anti-skid inoperative is roughly 20 knots lower. Speed brakes do not extend automatically, and the auto brake RTO function is inoperative. First officer flight instruments are lost. If the first officer was pilot flying, controls should be transferred to the captain on ground before or at rotation. The FO can assist in speed readings. On the early NGs, switch the flight deck dome light to bright during ground run and read V1 and VR from the standby airspeed indicator. If you do not manage to read the standby ASI or you do not remember VR, rotate the airplane when reaching the last 3,000 feet of remaining runway, indicated by the red and white centerline lights. After liftoff, electrical trim is inoperative. Place cutout switches to off and use manual trim. Flap position indicator is inoperative. Maintain takeoff flap setting. Maintain airspeed between yellow bars on speed tape or aim for the actual flap placard limit speed minus 10 knots. The airplane is unpressurized. level off at minimum safe altitude, the overall altitude alert to level off is inoperative, and the auto throttle has disconnected. Advise ATC and request radar vectors do not continue RNAV without flight director. Now, if this happens in climb or cruise, MRG says there is no need for an immediate rush descent, except that chances for a successful APU start increase below 25,000 feet. Consider maintaining level flight until completion of the initial steps of the non-normal checklist. For example, the attempt to reconnect the generators. If neither generator can be reconnected, start your descent. Advise ATC that you have lost PRNAV and RVSN capability. The outflow valve remains stuck in its last position. If climb is discontinued, engine bleed air output may be insufficient to maintain cabin pressurization, and the cabin pressure altitude may reach 10,000 feet and above. Use manual mode to control pressurization. Now, if this happens on final approach, if flaps are at 15 or more, consider continuing the approach, except for landing on short or contaminated runway, since anti-skid and auto brakes are inoperative. Maintain target speed according to the actual flap setting, extend speed brakes manually upon landing, maintain directional control on the runway with nose wheel steering tiller. Now let's go and read the checklist. Condition: both engine-driven generators are off. Note: at high altitude, thrust deterioration or engine flameout can occur. Engine gen switches both on, one at a time. Choose one, and let's have the panel here available. A single source of light stays illuminated. Go to step 3. Both source of lights stay illuminated. Go to step 5. Both source of lights extinguished. If that's the case, yield amper switch on. Go to step 17. If a single source of light stays illuminated, yield amper switch on. Choose one. APU is available for start. By the way, if we read this comment here, each APU start attempt reduces battery endurance by approximately 7 minutes. Only one APU start attempt is recommended, especially on airplanes with single battery. Okay, that's important. So if the APU is available for start, note APU start attempts are not recommended above 25,000 feet. APU start. When APU is running, APU gen switch affected side on, and we'll go to step 17. If APU is not available, plan to land at the nearest suitable airport. Only one main AC power source remains. Go to step 17. Both source of lights stay illuminated. Choose one. APU is available for start. Bus transfer switch off. Electric hydraulic pump switches both off. Note, APU start attempts are not recommended above 25,000 feet. With both buses off, only one start attempt is recommended. Multiple start attempts reduce standby power capacity. APU start, we'll go to step 6. APU is not available, go to step 14. Step 6 says when APU is running, APU gen switches both on, one at a time. In these models here, we check the remote control circuit breaker. We choose one. RCCB remote circuit breaker is tripped. Reset circuit breaker, only one reset is allowed. Go to step 9. RCCB remote circuit breaker is not tripped. We go to step 9. Step 9 says choose one. A single or both source of lights extinguished. We'll go to step 10. Both source of lights stay illuminated. We'll go to step 14. Step 10 says bus transfer switch auto. This restores power to the remaining transfer bus if one source of light stays illuminated. Electric hydraulic pump switches both on, one at a time. Yield amper switch on. Plan to land at the nearest suitable airport. Only one main AC power source remains. Go to step 17. Both source of lights stay illuminated. Avoid icing conditions. Note, flight in icing conditions can result in erroneous flight instrument indications. Plan to land at the nearest suitable airport. On these models, it says a note, A fully charged battery supplies a minimum of 30 minutes of standby power. This is if we don't have the auxiliary battery. In case we have one, the fully charged batteries supply a minimum of 60 minutes of standby power. Step 16 says the right IRS will operate on DC power for 5 minutes only. Step 17, both the captain's and first officer's primary attitude displays are operative and ATT flags are not shown. Both the captain's and first officer's primary attitude displays are failed. We'll go to step 19. Only the first officer's primary attitude displays failed. IRS transfer switch, both on left, do not engage either autopilot. Go to step 18, which says a single source of light is illuminated. Plan to land at the nearest suitable airport. Only one main AC power source remains. Both source of lights are extinguished. Both source of lights are illuminated. The left IRS will operate as long as battery power remains. Plan to land at the nearest suitable airport. Step 19, and let's read what this note says. Action is irreversible. Do this step only if both the captain's and first officer's primary attitude displays are failed. IRS mode selectors both ATT. Maintain a straight and level constant airspeed flight until attitude displays recover, approximately 30 seconds. The primary attitude displays stay failed and the set IRS heading prompt on the position init page is blank until the attitude mode alignment is complete. Step 20 says enter magnetic heading on the pause init page or on the overhead IRS displayed unit by selecting heading STS. Note, the map display is not available. Note, periodically enter updated heading on the position init page or on the overhead IRS displayed unit by selecting heading STS. And the last step, 21, do not engage either autopilot. So now if we talk about the source of non-normal checklist, and here we have the panel, condition, the transfer bus is not powered by the last selected source. Choose one. Both source of lights are illuminated. Go to the loss of both engine-driven generators checklist on page 6.4. Only one source of light is illuminated. Go to step 2, which says engine generator switch affected side on. Choose one. Source of light extinguishes. Source of light stays illuminated. If that's the case, we'll go to step 4, and then we check if the APU is available for start. If it is, APU start. When APU is running, APU gen switch affected side on. Go to step 5. APU is not available. Plan to land at the nearest suitable airport. Only one main AC power source remains. Step 5 says choose one. Source of light extinguishes. Source of light stays illuminated. Plan to land at the nearest suitable airport. Only one main AC power source remains. Now, if we talk about the standby power off non-normal checklist, and here we have the panel where this light is, it says condition one or more of these buses are not energized. AC standby bus, DC standby bus, battery bus. Standby power switch to battery. Now let's read a couple of notes from the MRG. It says verify the standby power DC and AC indications to find out which bus has actually failed. To the right, you can see the normal values for the standby power. In case DC and AC values indicate both normal, the battery bus is the culprit. A zero hydraulic system brake indicator and a frozen first officer MCP course selector confirm failure of the battery bus. Now, one more thing to read about this one, the standby power off amber light should extinguish when the standby power switch is placed to BAT. If the light remains illuminated and systems connected to the standby bus receive power prior to and after switching to BAT, the amber announcement is most probably a false warning. All right? I thought that was important to know. Let's talk about the TR unit, non-normal checklist. Here we can see the light condition. One or more transforming rectifiers are failed. Now, depending on the model, it says do not use the AFDS approach mode during an ILS or GLS approach. And for this one, do not use the AFDS approach mode during an ILS approach. Note, autoland is not available. Note, the AFDS approach mode can be used during an instrument approach using IAN. Now, if we read this note about the TRs, it says if TR unit light is inoperative, the flight can be dispatched as per MEL 2415. However, the TR unit light illuminated prior to takeoff is a no-go. Failure of a TR unit does not require an immediate landing at the nearest suitable airfield. However, we need to keep in mind that according to the MEL, the 2406, we have a no-go for the next flight. So we have to consider diversion or turn back to an airfield that offers maintenance repair. Well, let's talk about the transfer bus off, non-normal checklist. Condition, the transfer bus is not energized. Engine gen switch affected side on. Choose one, transfer bus off light extinguishes. Transfer bus off light stays illuminated. If that's the case, we have to go to step 3, which says APU is available for start. APU will start. When APU is running, APU gen switch affected side on. APU is not available, plan to land at the nearest suitable airport. Only one main AC power source remains. All right, so now we will talk about the electrical system, FCOM Volume 1 Supplementary Procedures, and let's watch the following video in order to review these procedures. Okay, guys, now let's review the supplementary procedures for the electrical system, and we will be talking about the electrical power up and the electrical power down. And we can find these supplementary procedures on the FCOM Volume 1. For the electrical power up, the following procedure is accomplished to permit safe application of electrical power. Battery switch, guard closed. Note, do not move the airplane until integrated standby flight display ISFD alignment is complete. Standby power switch, guard closed. Alternate flaps, master switch, guard closed. Windshield wiper selectors, park. Electric hydraulic pump switches off. Landing gear lever down. Verify that the green landing gear indicator lights are illuminated. Verify that the red landing gear indicator lights are extinguished. If external power is needed, verify that the ground power available light is illuminated. Ground power switch on. Verify that the source off lights are extinguished. Verify that the transfer bus off lights are extinguished. Verify that the standby power off light is extinguished. If APU power is needed, verify that the engine number 1 APU and the engine number 2 fire switches are in. Alert ground personnel before the following test is accomplished. Overheat detector switches normal. Test switch hold to fault in up. Verify that the master caution lights are illuminated. Verify that the overheat depth annunciator light is illuminated. Okay, we'll continue here. Verify that the fall light is illuminated. If the fall light fails to illuminate, and this is important to highlight, if the fall light fails to illuminate, the fall monitoring system is inoperative. Verify that the APU dead inop light is illuminated. Do not operate the APU if the APU dead inop light fails to illuminate. Test switch, hold to overheat fire. Verify the fire warning bell sounds. Verify that the master fire warning lights are illuminated. Verify that the master caution lights are illuminated. Verify that the overheat dead annunciator light is illuminated. Master fire warning light push. Verify that the master fire warning lights are extinguished. Verify that the fire warning bell cancels. Verify that the engine number 1, APU, and the engine number 2 fire switches are illuminated. Verify that engine 1 overheat and engine 2 overheat lights stay illuminated. Note, the wheel well fire warning light on the overheat and fire protection panel may or may not illuminate when testing on DC electrical power only. For accurate testing, do the wheel well fire detection system test after AC electrical power is established. Extinguisher test switch, check. Test switch position to 1 and hold. Verify that the 3 green extinguisher test lights are illuminated. Test switch, release. Verify that the 3 green extinguisher test lights are extinguished. Repeat for test position 2. APU, start. Note, if extended APU operation is needed on the ground and the airplane buses are powered by AC electrical power, position an AC-powered fuel pump on. This will extend the service life of the APU fuel control unit. If fuel is loaded in the center tank, position the left center tank fuel pump switch on to prevent a fuel imbalance before takeoff. Caution, center tank fuel pump switches should be positioned on only if the fuel quantity in the center tank exceeds 453 kilograms. Caution, do not operate the center tank fuel pumps with the flight deck unattended. When the APU gen off bus light is illuminated, APU generator bus switches on. Verify that the source off lights are extinguished. Verify that the transfer bus off lights are extinguished. Verify that the standby power off light is extinguished. Verify that the APU main light is extinguished. Verify that the APU low oil pressure light is extinguished. Verify that the APU fault light is extinguished. Verify that the APU overspeed light is extinguished. Wheel well fire detection system test. Test switch, hold to overheat fire. Verify fire warning bell sounds. Master fire warn lights. Master caution lights and overheat dead annunciator light illuminate. Fire warning bell cutout switch, push. Verify that the master fire warning lights extinguish. Verify that the fire warning bell cancels. Verify that the wheel well fire warning light is illuminated. So that completes the electrical power up. Let's review the electrical power down, which is very simple actually. Electrical power down, this procedure assumes that secure procedure is complete. APU switch and or ground power switch off. If APU was operating, delay approximately 2 minutes after the APU gen off bus light extinguishes before placing the battery switch to off. Battery switch off. Okay guys, with this video we complete the electrical system today. I hope you liked the video. If you did, please give me a thumbs up. And if you're not subscribed to my channel yet, please do it now. If you think these videos could be useful for somebody else, please share them. And that's going to help me a lot to grow this channel. For the next video, we will talk about ditching. So stay tuned for that one. Until then, guys, please you take care, and I hope to see you soon.